Thank you.
Thank you.
All right. All right, thank you very much. Yes, so last year I came here to talk about a couple of things about graphene and just analytics. But then, when I came back, I started thinking about all the other things that are beneficial before even going forward for, talking about analytics is to understand your data. So today we're going to be talking about data and also the meta attack framework. So you guys already heard from me. So if you go to that link at the bottom, it's pretty much my GitHub. If you want to talk about a few projects with me, I would love to do that because I like to talk about Helk and all these things. And I'm also a former Capital One senior threat hunter in Virginia. And that is what I started also working with a lot of, I would say, data, like more than 300,000 endpoints, and then including the cloud. So I think that was an awesome experience to know exactly how it goes from 10,000, 2,000 endpoints all the way to a massive amount of data.
Hi everyone, my name is Jose. I go by CyberPanda in Twitter. I'm currently a cybersecurity student at Northern Virginia Community College in the US. I like to contribute to open source projects with my brother, and also a former senior business intelligence analyst from UNACEM Peru.
Yep. Oh, and you can follow me in CyberWar Doc. Sorry, I didn't mention that. Okay, so the agenda for today, we're going to be talking about a little bit, threat hunting programs with data, all the way to start, coming up with the methodology to start mapping your Windows event logs or your, security in general, security event logs in general, to the attack framework, for example. And then we're going to talk about a little bit about Mordor at the end, and you guys are going to know why in a little bit. So threat hunting and data. So I believe that a lot of organizations are doing this already, right? They're putting together their programs, they're doing all the way from the pre-hunt activities, all the way to defining their hypothesis, analytics, hunting, reporting, all the way to enhancing security controls. Everybody's doing that already, right? The problem that I see a lot every time I go to a company is that they focus so much on that, but they don't focus at all into this problem that they have, which is there's a lot of data. There's a lot of data that is being generated that if you don't understand exactly what that data is, then it's hard to implement all the other processes that you have in there. Some other organizations are even skipping some of the steps on their own programs, and they're just giving a console, a search bar to a security analyst and say, go and hunt. And all they do is they just Google, they find a script or find a specific query, they run it, and they just call it a day, and they say this is a hunting engagement. So there's a lot of things going on, right? All the way from a basic program, all the way to just giving a search bar. But at the end of the day, if you don't care about your data, it doesn't matter what you're doing, talent, technology, it doesn't matter if you're the best at hunting. If you have a data swamp rather than a data lake, it's gonna be very, very hard to even do your job. And I have experienced that. I actually have performed IR and also hunting engagements on that, and it's not fun at all. It is very painful, and a lot of people just get frustrated because that's one of the biggest problems out there. We talk about how to do procedures, how to put together your program, some nice slides about how you can link different teams together and all this stuff, work together with a red team. It's amazing, right? But in reality, when you go to your organization, that's the problem at the end. And that's going to, of course, define if you're going to be successful or not. So you might be asking yourself, okay, so more data, then more problems. Yes and no. So if you have data, it's going to be great if you're going to do an investigation, if you're going to use it to find anomalies, outliers, and things like that. But at the same time, you have to understand what it is that you're actually collecting. And when I ask this question, it actually has another question, which is, do you know what you're collecting? And do you know what data you're collecting? Two different questions. Because when I say, do you know what you're collecting, the answers are, yes, I'm collecting process monitoring, I use my EDR, I use Sysmon, I'm collecting all this. My question is, no, but do you really know what you're collecting? What is the data behind those data categories or names that you have in an Excel sheet? What's going on with those events? Do you understand exactly what's under that? And most of the time, the answer is no. So how you might be doing it to start at least getting a little bit closer to talking about data and also your hunting engagements. So a lot of organizations that we go to, right? Miter Attack came last year to talk about their emulation plans and things like that. And it's been, for the past year and a half, I believe, it's been crazy the amount of people that I talk to and they implement Miter Attack. So that should be pretty much everywhere in your hunting program. And some organizations that I go to, they say, hey, I have an idea. Miter Attack has these metadata called data sources, and I can start mapping all my controls to those data sources that are going to map to a technique. So easy, right? And then before we continue, a data source for MITRE ATT&CK is considered a information collected by a sensor in order to allow you, to validate the detection of an adversary technique. So if we take this concept, right, you can go from mapping a technique to data sources that will map to other things in MITRE ATT&CK, which is awesome how you can just have relationships in there. And you can just start doing this, right? And a lot of companies have solved this, right? They think that they have solved this. They say MITRE ATT&CK says process monitoring, I have my EDR. MITRE ATT&CK says Windows security event logs, I have my domain controller. And that's it. They just check the box and I already have my coverage. Well, it doesn't work like that, right? We have Windows security event logs, we have more than 400 events. If you map a technique to Windows security events, you're mapping more than 400 events to just one data source, and there is not a way to understand exactly what it is that you need per technique if you only say, I need Windows event data sources. So if you're doing this and you feel that you don't have to move forward, right, you might be asking yourself, why are we here, right? The main goal is to start sharing a little bit of the value of it is to understand data when you start hunting. At the same time, we want to define a methodology to allow companies to start mapping their security events all the way to an attack data source. And at the end of the day, also, we want to make sure that at this conference, which I like the concept from a blue and red team perspective, if you're a blue, I want you to understand exactly what data sources you can use to validate the detection of specific techniques. And from a red team perspective, what actually you look like in the environment. Every action that you make or take is going to be logged somewhere or somehow. So we want to make sure that we identify how you can start mapping actions of an adversary to specific events as well. So we're focusing on these right now. So we're going to start defining a methodology. And it's going to be very simple. I mean, we're going to just start going through attack data sources all the way to start mapping specific events to attack. And we're going to start doing some validation to make sure that our mappings of security events to certain actions actually make sense when you start putting it against a specific technique or variation of a technique. So we're going to explore attack first. And how do we do that? But first, before that, people also ask me, why do you use attack to start mapping data sources? Why do I need attack? I can do it myself just without thinking about attack. Well, attack is a great, I would say, project or framework to start, and then you can build on the top of that, right? Because nothing is perfect, right? You can build on the top of that, and if you feel that something could be updated, it's an opportunity for collaboration. Don't reinvent the wheel, right? If you're going to start creating your own categories mapped to your own techniques, that sounds to me like MITRE ATT&CK already. So you should be able to at least use something that is out there for the community and start building on the top of that. The way how I access MITRE ATT&CK is by querying the data through their public taxi server in Sticks content. You might ask yourself, what's taxi in Sticks? So I have this slide here. So taxi would be just the application, application protocol to exchange cyber threat intelligence over HTTPS, and we have Sticks. It's pretty much the language, the format where the data is presented and serialized as well. So, for example, on May 4th of last year, MITRE ATT&CK pretty much announced that they were pushing all their information as well into this public taxi server. So when we talk about Sticks data, that's an example how a technique turns into an attack pattern, grouped on intrusion set, and so on. So you have to now understand what it means when you query data directly from the taxi server. So because of that, I built my own library, or I would call it more like a wrapper, on the top of MITRE's two libraries, Python Sticks and client and taxi client. And those two allow me to play with that data, query that data, and start serializing it and transforming it in any way that I want, or filtering that data as well. You can install this. It's pretty much via pip, just pip install. I updated yesterday. I like to update my tools before I talk, and it's pain in the ass because sometimes you're like, this is going to be awesome, and then something breaks, and then you have to make sure that it's done before the presentation. And there is also a couple of Jupyter notebooks, which are just web documents that allows you to run queries in a specific programming language. You can save the output on that document, and you can share that document with anybody else. That's the beauty of that. So there is a folder for that, and all the instructions on how to do it. So now you have a way to use the library to query MITRE ATT&CK, or you can use the Jupyter notebook, where you can use the library and still map MITRE ATT&CK. So what does that look like, right? So you just pretty much import the library. You initialize a specific class, and then you pretty much do dot and tap, and it was going to show you all the specific methods that are available. The reason why I do this is because if you are using the MITRE ATT&CK or just the MITRE itself, the MITRE sticks libraries, you have to write a lot of different lines of code in order just to make a simple query, like give me all the techniques from your database. With this tool, you can just do all techniques equal to using the method get all techniques, and you get every single technique in a sticks object format. And then you can just play with that data, and you can just import it to another application. You can do whatever you want with it. If you want to do it through the website, good luck taking snapshot of every technique and then put it in a format that you want. So this at least allows you to have everything programmatical way. So if you want to have ATT&CK in your applications, this would be a good way to do it. Keep in mind, there is 500 techniques apparently for all the matrices in MITRE ATT&CK. There is this concept of revoked techniques. So MITRE ATT&CK pretty much will save techniques as well that have been disabled or revoked or taken out. So you have to make sure that if you work with MITRE ATT&CK data through their APIs, you take the revoked ones out. There is a method that allows you to see a specific technique just by the name. And as you can see, there is a specific field that says revoked. So I did that for you already. So you can just use another method called remove revoked, and you can get pretty much all the techniques that are available in the MITRE ATT&CK framework. And you can play with those and start understanding the data sources behind each technique, which is my main goal.
So the MITRE ATT&CK team distribute these 485 techniques in 3 matrices. It's the enterprise, the mobile, and the pre-attack matrix. These are the last the last numbers we have after applying our library. Mm-hmm. Now, from a data source perspective, almost 50% of the techniques have data sources. The question here is, what's happening with the other half part of techniques, right? So basically, the idea here is this could be the reason this is happening is because maybe some of these techniques are not happening inside your environment where your sensors are collecting data, such as, for example, the pre-attack techniques. Or this is also an opportunity to collaborate with the attack team. If we split all the techniques with and without data sources by matrices, right, we can find that all the techniques that do have data sources belongs to the enterprise attack. Mm-hmm. Something very interesting is that there are 4 techniques for the enterprise attack that do not have data sources. So this is a big opportunity for us to collaborate with the attack team.
Yep. So there's something you can do this weekend if you don't have anything going on. Yeah. You can do that
after this conference. Now, looking at the information about all the data sources that we have in the MITRE ATT&CK framework, the most relevant data sources are process monitoring, file monitoring, and process command line. And this is because, for example, with process monitoring, you can start analyzing or validating the detection of at least 169 techniques out of the 240. But before we continue with our analysis of the attack framework, there is something very interesting here, is there are some data sources names that are related to a specific platform. In this case,
Windows, right?
Windows, yeah.
Yep.
Yeah, they are related to the Windows platform.
So something that you can do with this library is you can get all the techniques by a data source. So in this case, if I want to know all the techniques that are mapped to PowerShell logs, there's actually 4 of them. And if you go just do a basic loop, please don't judge my Python. I'm actually still learning Python. You can actually get a technique mapped to a platform. And as you can see, 2 out of the 4 are mapped to more platforms beyond just Windows. So that's very interesting because when you start playing with this data, you got to be careful because you cannot just say one data source PowerShell logs is helping me in 3 platforms, Mac OS and Linux and Windows. So keep that in mind when you do this type of analysis.
Yeah. So and if we apply the same concept for all these data sources, PowerShell, WMI, Windows, error reporting, Windows registry, or Windows event logs, we need to be careful. If we have these data sources, we cannot consider that we are covering all the platforms, right? Mm-hmm. These data sources only works for Windows, so we need to be careful with that. Now, going back to our graph, is we already said that the process monitoring is the most relevant data source, right? Because is from a coverage perspective, you can start analyzing at least 169 techniques. But the question is, can we only use one data source, right, to analyze the variation of a specific technique? Well, the answer is that we can only do that in 21 techniques. The other 219 techniques requires at least 2 data sources. So for us, the number of data sources that you require or that are recommended to validate the detection of a specific technique is related to how much context do you need from your data to validate the detection.
Mm-hmm.
So now we are not talking about just one data source. We're talking about groups of data sources, right? So this is the top 15 groups of data sources that the attack team recommends to work together, right,
Mm-hmm.
on all the techniques. In this case, for example, file monitoring, process command line, and process monitoring. If you start collecting these 3 data sources, you can start analyzing at least 42 techniques.
Yeah, it's like at least 42 that require the combination. But of course, if you look up the first, 1, 2, 3, at least it covers, a combination of file monitoring and process monitoring only. So the idea with this is that I have clients that say, I'm good with 169 techniques because I do have process monitoring. That's it, so we're just going to go with it. No, it doesn't work like that, right? That's just part of the context that you need to do analysis. So now that we understand at least attack data sources from their perspective, right? That's something that they're providing to us so we can at least get some information. We can start documenting event logs that might be related to those data sources. Every time we think about this technique, for example, they recommend these 3 data sources. Right away, you think about 4688 from my Windows security event logs, and that covers both of the data sources. We actually have a recommendation that process command line should be inside of the other one, but that's something that we can talk about later. But this is beyond just 4688. Process monitoring could mean process termination. It could mean process monitoring creation from another data source, or a process accessing a process writing to a process. There's a lot of things that can happen with a process monitoring perspective. So you need to define that and document that. Otherwise, it's not going to be valuable at the end. So you can start doing this by applying this concept that I learned also from working at Capital One, which is the data dictionary concept, which you have to define and understand what it is that you're getting per each event. All the way from the field level to the description of the field. You can talk about data types as well, so that way you understand what it is that you're querying. Is this an integer and a string? And this is very interesting. For example, if we look at event ID 3, we have like source port, destination port. Those are numerical values, right? Those are integers. But what can I do with that? We can start doing some basic, like if we take, for example, one field, we can just do basic stack counting. We can see the most frequent, least frequent, ports being used, frequency over time. We can do a lot of stuff like that. But when you start thinking about this is a number, so I can actually do some type of descriptive statistics, average, max, median. So can I do that? Yes, you can, but at the end of the day, if you do that to a port, I don't think that that's going to have any meaning to you. You cannot connect to a port, 10.5, 0.567, because that's the average of ports in my environment. It doesn't work like that, right? So when you talk about that concept, then you have to understand the events themselves and the types in a different way as well.
Yeah, because if we see this column of type of data, right, is giving us more an idea of the format of the data, right? But if we use another perspective, let's use a mathematical perspective. If we start describing our data with type of data, it could be qualitative or quantitative data. Qualitative data, the concept is really basic. You can describe your values using letters, numbers, or symbols. And in quantitative data, you can use only numbers to represent your values, right? So the idea is, for example, Roberto already talked about source port value, the
source port value? Yep.
Yeah, the source port value. So this value is a quantitative discrete value. What is the meaning of a discrete value? It's like in a range of value, you can only have specific values, right? So using the descriptive analytics like the mean or the average, or maybe the standard
Max,
deviation,
median,
right?
Yep.
Most of the time, the value is not going to mean anything. But for example, if we apply the same concept for a quantitative continuous data, which is in a range of data, you will have infinite values, right? Like for example, bytes in or out your network, you can find what is the mean, the standard deviation, all these descriptive statistics. If you put this information in a graph, let's use a box plot graph, you can start identifying what values are outliers or atypics in your environment. So that's the way you can use this math approach to prioritize your actions or the analysis that you're doing.
Yeah, so for example, yesterday I was talking about a little bit, for example, someone asked me about machine learning and all the stuff out there. And to me, it's like, well, if we're gonna talk about machine learning and all these concepts that are crazy out there that everybody uses for marketing, from our perspective, we need to understand this, the data to be described like this. If I don't understand my data described that way, I cannot come up with a use case for a specific data source. So what we're gonna be doing is actually creating data dictionaries that gives me a basic data type for a format, but then also give you a little bit of the mathematical type for that field. And that's what, if you talk to a data scientist, they love that because they want to know exactly what are the values they're going to be working with so they know what they can apply to that specific data. So that's very, very useful. Another reason why you should be doing this, especially from the red team perspective, so our colleagues, well, my colleague, Matt Graver and Lee Christensen, that's their presentation in Black Hat last year. They talked about documenting Sysmon, for example. What are specific fields there's going to be the attack influence rating is going to be higher? What are the fields that they can actually manipulate? What are the fields that they can easily just touch and then change? Well, they have to do data dictionaries in order to understand that. So if a red teamer is doing it, why isn't a blue teamer doing it as well? So in general, we all need to be doing data dictionaries for the data that we collect and the data that we generate as well. So it goes for both sides. Next step, we're going to develop a data model. In a data model, now that we understand our data, from an attack perspective, now that we understand our data also that we're collecting from specific field levels, descriptions, we can start now defining the structure or understanding the structure of our data. MITRE has their own data model, that's the link over there, and they also use, once again, sticks definitions or specifications to map specific objects that they can identify on their data sources. When you think about a data model, some of you guys understand these concepts, might be thinking about a database. Well, it's like a similar concept, how you can start structuring your data so that it makes sense to be stored in a database, right? This gets applied also to, for example, CTI, right? When you can use a basic graph knowledge, for example, to start mapping specific entities. Each entity can have specific properties inside, and you keep a relationship across all of them. Why can't we start doing that with security event logs, for example? We have every event log that we have, we're going to identify a user, a potential process, an IP, a file. Well, there's going to be relationships across these entities that we find in our event logs. All those events have properties, and they also have relationships that we can identify across those events. At the end of the day, if you're doing Sysmon, you can actually have this type of basic data model, which allows you to understand what it is that you can do with Sysmon. This is very helpful for an incident response perspective, for example. If somebody finds an IP or a process, you can pretty much think about the other possibilities that might be attached to that specific entity, for example. Or from a hunting perspective, or from a red team perspective, if I'm making a specific action, that's what it will look like on Sysmon. You can apply this on an enterprise tool like Carbon Black, and as you can see, there's like a similar way. If you start reading one by one, you can pretty much see also Carbon Black giving you certain relationships in the data. So that's very important because that's how you can actually start telling somebody, I do need Sysmon, I don't need Sysmon, I need an EDR solution, or I don't need an EDR solution. You have to be able to define that. If you can do that, if you say that you want to use an EDR because I have some cool shirts and a nice calendar, good luck with that. It needs to be defined this way, from our perspective. So going back to our technique from a data source perspective, now that we understand what are the different events that might provide specific sub-data sources for the attack data source in there, we can apply our data model and start mapping what are the relationships that we find in each sub-data source that then will be related back to an attack data source. This is very interesting because then I'm going deeper into what does attack data source actually mean to me. So when we talk about now process monitoring, then I understand now that this means something like this now. Not just a data source name that I just map to a tool directly. Now there is a process in between. I can do the same thing with registry, for example, right? I can find relationships inside of my data sources that provide those sub-data sources mapped to attack data source. But this is very interesting because I'm identifying relationships about a process in a registry. But what if I want to do a user point to a registry? If you're using Sysmon, Sysmon does not give you that, right? Sysmon does not give you the username. So if you're running an analytic saying username blob and Sysmon event ID 12, 13, or 14, you're not going to get anything. And you might think it's a high fidelity rule, right? If you want to do some type of registry map to a user, you might need a SACL, right? A SACL pretty much is a system access control list. And you can use this SACL mapped to a Sysmon, for example, registry. If I create a SACL on the Sysmon registry, every time my adversary wants to query or access the information about Sysmon through the registry, I'll be able to get this event, which is going to give me the specific user. It's going to give me the registry mapped to a process. So that's very interesting to me because from a red team perspective, this is what you will look like if you query Sysmon and I have a SACL in it. And from a detection perspective, I want to know that I have some use cases that I can work with. I have process to a registry and user to a registry as well. So at the end of the day, you might be asking yourself, okay, it still does not make sense, right? Yeah, this is probably a little, like I don't understand how this could be helpful when I execute 100 or stuff like that. Let's say we're using WMI to spawn a new agent to move laterally, right? So you can just do that with Empire's module. From a detection perspective, it looks like this to me. There is an authentication going on, specific port. Every time you do an execution through WMI on a destination, it's going to be hosted by WMI PRVSC as a parent process, and then the parent executes whatever you want it to execute, and if you are doing it to launch an agent, it's going to then make a network connection. I can map that with my data model and say I have event ID 1 and 3. They both can be joined by a specific field, the process GUID, and I can actually say, I have WMI PRVSC as a parent. I don't care about the child. If the adversary uses PowerShell, CMD, or any other process that they want to use, or names or anything, I don't care about that. I care about the specific behavior going on in here. WMI, executing something, and then making a network connection. That could be translated to a query, for example, a basic SQL query, which can be used by any other tools that support SQL. Right? So you can pretty much have this, and at the end of the day, you will be able to find that type of behavior, which these slides are going to be available, so the query pretty much was put on the top. Do this in your environment. Try to find every single parent process that is WMI that is executing something that then makes a network connection. That does not happen that often. So now that we understand our data, we documented it all the way to the field level, we understand the specific data types, we understand the structure of our data, relationships that we can find, we're going to start then now mapping it all the way to attack in a way that will make more sense to me. Where I could say, I have this data, I have these specific event IDs, mapped to a specific relation that I can find all my data sources, all the way back to an attack data source, for example. That to me is so valuable because I will be able now to understand that I have certain possibilities just by one specific attack data source, and I can also create, built on the top of attack, and say every time we say process monitoring, those are the possibilities that we have. And of course, those will change depending on the variant. If the variant of the technique calls for a process accessing a process or writing to a specific thread in the process, then now you can pretty much say this technique requires process monitoring and requires process writing to another process, pretty much. So at the end of the day, the idea is to have this documented in a way that will make sense. I have this link in a project called Awesome that is going to allow you to see exactly what certain actions mean back to an event ID. I showed this to our red teamers. They loved it because now they say, if I go to this list, I can just type, if I want to look at a relationship between a process to a user or a user to an AD object, I just filter all these and I can find all the event IDs that will give me that relationship. And then they can pretty much go on and do whatever they want with it. It's in this project right here. You have dictionaries, data model, the mapping to attack, and also a common information model. It's a project that we're building to start documenting all this. So we're doing a lot of the heavy work already. We will have some, some contributors and see where this actually takes us. And we have conversations with attack to update their attack data sources to sub data sources. So that will be interesting to see that happening as well. So how does that look like from a hunting perspective now that we understand the methodology? Well, you have to understand that if you have a program like this, you have to understand where data actually fits. Data will fit before you even try to build your analytic, because otherwise you will not understand the analytic itself or the possibilities that you can use with the data to build potential analytics. Analytics, by the way, goes all the way from a basic query all the way to a potential statistical model that Lucho was talking about. Oh, Jose Luis, sorry, I call him Lucho all the time because that's how we talk to each other. And then data also fits before you even execute the hunt. And that will define if you're going to be successful or not. If you have this crazy technology, people with so much talent, dream team, right? Dream team in there, going on hunt, and you're not collecting the data that you're defining on your analytic, good luck with that. So the data quality assessments, which are also part of other presentations that we talked about, are very important as well. But we just want to talk about how data really will define how successful you could be for an engagement. So we're going to just do a quick validation in here. We're going to talk about overpass the hash. In this case, we have this technique, pass the hash first, right? Which is the basic concept is to use, to authenticate to a box, without using the explicit credentials or clear text from a user. That's just the basis of pass the hash. There is a variation of pass the hash, right? There is an overpass the hash, which is going to use Kerberos authentication, right? You can pretty much get that ticket or that hash, and you can pretty much, use it to request a ticket. So what does that look like? Just in case the basics of Kerberos, right? You have your password, gets go through a one-way function. Depends on the functionality of your domain controller. You have specific keys. You can use that key then to request a ticket, get the ticket back, use that ticket to request other service tickets, and then you can pretty much access other services in the network. There's the basics of Kerberos. Overpass the hash basically just gets the key or the hash that was just stolen, and you can use that to pretty much start the whole Kerberos process as well. This is a question for red teamers and blue teamers. Which one is Mimikatz and which one is Rubius? And we'll talk about Rubius in a little bit, but at least which one is Mimikatz? Anybody, left or right? Okay, time is up. Well, Mimikatz is the left, and Rubius is the right. We have sacrificial logon sessions being done by Mimikatz when it does the overpass a hash. The reason they do that is because they don't want to deal with the current logon session, so they create a sacrificial logon session. They inject the hash into LSAS, pointing to that session, and then that pretty much kicks in the whole Kerberos authentication process. With Rubius, you have a similar concept, but Rubius does not touch LSAS, does not want to deal with that, and crafts the whole packets to request a ticket, gets the ticket back, parses it, and then imports it to the sacrificial logon session. So it doesn't let LSAS doing it. Rubius is a tool built by Harmjoy or Will Schroeder from SpectreOps, and it uses C# to start also providing most of the functionalities of Kikyu, a project also by Benjamin Delpy. And I'm going to do a quick demo into how exactly that works, and so that way we have some time still. Cool. So if I just execute this, we're going to just do an overpass the hash. We're going to use Pedro is my dog. I want to make him famous. And then we have the commands that we're going to use with Rubius. We have our victim. It's an admin. We do have our domain controller. And then what I do with my victim is I try to understand if it's possible to query, do a directory listing on the domain controller. Of course, access denied. Pedro has access to that, and I only have the hash. So let's just use Rubius for that. And it creates a new process, which is going to be the one with the sacrificial logon session. And then Rubius already imported the ticket on that session, so I should be able then to query, right, the domain controller. Nothing crazy. I mean, this has been done by Mimikatz for years. But the process you can see with Rubius is going to create a process with net only. It's going to do a logon type 9 new credentials using the hash that was stolen. And it's going to, of course, create the request or craft it. It's going to receive the ticket before it's connecting to the domain controller over port 88. It's going to request a ticket, get the ticket back, and then it just imports the ticket. So that's very interesting. It's actually a pretty cool attack. So let's just go back to this from current slide. Yep. Okay. So this is pretty cool, right? Because now we have this behavior that we're identifying from Ruvius. We can start mapping Ruvius to specific actions going on in here, where we can see successful authentication locally with logon type 9 with new credentials. We can see also Ruvius creating a process, but then at the same time, we can see also Ruvius connecting to a domain controller, and then at the end, it's gonna be the one handling the whole curve of authentication. I can start mapping all of that, for example, to specific events. So I can at least say, this is what I would like to use from a relevant data source perspective to start approaching Ruvius a little bit. One interesting piece in here is that you can see I have Sysmon event ID 3 and 5156 from security. I've seen clients saying, I don't need Sysmon. Some other people say, I don't need security logs because Sysmon is doing it. Well, you have to understand that Sysmon, for example, gives you the username and the destination host. And how do we know this? Because we're doing data dictionaries, right? There's no other way to know what fields are available. When you do it with 5156, you don't get that information. So if you're looking for stacking the values of users, 5156 will not be your friend, right? Sysmon will be your friend. You can do this, still find the user if you link it with another event that will match, for example, a specific behavior, or you can do like a time-based type of analysis, but it gets a little complicated. So you have to know which events will give you what. When we talk about authentication also, here with Ruvius and Mimikatz, for example, you can see that Mimikatz, right? It's going to patch LSASS, and then lets LSASS do the whole process. Ruvius is not going to bother LSASS, so at the end of the day, you have this process that is not LSASS, is not a system user, and it doesn't have the signatures or anything from LSASS, and it's just talking to port 88, for example. So from a Sysmon perspective, you get more information, right? You get the system user, you have a regular user, probably, needs to be, of course, an admin, administrator kind of account. And then at the end, you get information about how it connects to the domain controller through port 88. So at the end of the day, if I can throw this to my either lab environment or to my environment in production, I can see that if I look for destination port 88, I will be able to find that most of them will be LSASS doing all that. Do this when you go back to your organization, please, because I've done it in a couple of organizations, and you will be surprised that there is only a few applications performing these connections to a domain controller through port 88. And so it's very interesting to start using that data and to start probably finding potential Rubius-like type of behavior, right? Because we cannot just say, you're going to find Rubius.exe, right? But at least you're going to find the behavior itself. So it's very, very interesting. From a sacrificial logon session, which one is Mimikatz and which one is Rubius? Which one is Mimikatz, left or right? Nobody? There's a quiz for red teamers and blue teamers. Somebody said right. I heard somebody say right, but Mimikatz is the left, and Rubius is the right. And probably have more information in here. That's because when you do a sacrificial logon session, you're just doing random dummy username, domain, and passwords to create that process with the sacrificial logon session. Mimikatz takes the parameters that you use for user, and domain, and then at the end you can pretty much have that in the log. So Mimikatz will actually, from my perspective right now, it will blend in a little bit more than Rubius, as you can see, because Rubius has a random strings. That's because there is a specific function there being used that applies the random strings for the values of the username, domain, and password. So that's how Rubius does it. So very interesting also thing to look at. And at the end of the day, you can find more sacrificial logon sessions across your network. If you're collecting the right data, we have Mimikatz, we have Rubius, and we have also bypass UA token manipulation, for example. So that's the one from token manipulation. Of course, that could be adjusted, But if somebody's using this type of behavior, at least you know that that data set would allow you to get to that specific type of behavior. You might be asking yourself, okay, that's awesome. How do I learn about these things also from a data perspective? Like, I don't have the expertise to do all these executions of all these techniques. There is a project that we released a couple of weeks ago called Mordor. Has pre-security events generated by specific techniques, and you might be asking yourself, why do we need this or need this? And this is of course a map to the MITRE ATT&CK framework as well. That's because if you want to do something like DCSync and you say, I want to learn about DCSync, like the abuse of AD replication services, because I know that my domain admins have this permission, so they can do it. So if there is replication in my environment happening from a non-domain computer or from a non-domain controller account, and it's happening from somebody else that doesn't have the $sign at the end, that is part of my domain controller name, you're going to start doing this crazy, building your detection lab and then standing all these boxes and trying to do all these things. Then you're going to find specific ways to do it through PowerShell, Python, through pure.NET. Just can do whatever. The data is going to be similar. The relevant data associated with that behavior is going to be a similar data set. Okay, I can do it through in-packet. Cool. I can do this. I'm not touching not my users. I'm just doing a whole relay as well, if I could. The data is going to be the same. The data is going to still generate this event, which is going to tell me that there is some type of access request to a domain object with the replication, also permissions as well. So the goal of Mordor is to allow for us to share those data sets, because we already took care of the whole execution. If you want to learn about execution, do, for example, the Atomic Red Team project. If you want to focus on the data directly, you can use Mordor. And how does that work? You can consume the data via Kafka Cat, which is a tool that would allow me to grab the JSON files, push them to a Kafka broker, and then you can pretty much, use it with LStacks, Jupyter Notebooks, any other application that can consume that data as well. This is how easy it is. Kafka Cat pointing to a Kafka broker. The help comes actually with the broker itself, so you can just point it to the port, specific port, specific topic, and then it's going to be in what is called producer mode, pointing to the specific JSON file that we share, and you're going to have data in 2 seconds. You can pretty much run a query on that data, and you'll be able to find whatever it was a DCSync type of attack. So this is very interesting, because now you can do your analysis on data set that has been already created in an environment that was similar to also what MITRE ATT&CK uses for their evals, with 3 computers, domain controller, a specific collector, and things like that. So we're doing all this stuff, and it's already documented. What's next for Mordor? And I only have a few seconds. We're going to release, today we're going to announce the APT3 data set, because last year, the attack team came with the APT3 emulation talk. And that was awesome from a red team perspective. I got the inspiration from that talk from here, and now I'm bringing the data set, which you can watch the other presentation about how they did it. I can show you the data set as well. So at the end of the day, you can pretty much point it to the APT3 data set, and you will be able to have that data as well. And before I leave, because that's my last thing here, it's already there, at least the definition of the APT3 data set. I do have the specific, I would say, resource files that I use for Empire. And at the end of the day, you can pretty much start playing with this. I'm releasing the data set at the end of the week, because I want to make sure that everything looks good in there. But at least all the things that I used are in there. And you can actually also access the specific file that was used as the playbook, because MITRE ATT&CK share their playbook, but they only share Metasploit and the other one as well, Cobalt Strike. I actually was able to map that all the way to PowerShell Empire. So I have every single command mapped to a technique, mapped to a specific step on the eval for MITRE ATT&CK, and now you have the data set as well. And that would be it. Let me just go back here. Thank you very much, everybody, and I hope that you guys enjoyed the presentation, and these are some links for you also to go back with. Cool.
Thank you, guys.